Hello, students. Today we are going to be learning about angles of rotation. All right, so the first thing we're going to start with is we're going to review those 6 different trig functions: sine, cosine, tangent, secant, cosecant, and cotangent for theta. So remember, theta, that's just that Greek letter that we use for our variable for any angle measurement that is unknown. So just like we often use x, when we're talking about angles, we're going to use theta, which you guys all learned about in geometry. So for this first problem here, we're given a triangle. We only know one of the side lengths and the hypotenuse. So remember, the hypotenuse, that is going to be the longest side length on our right triangle. We know this is a right triangle because it has that little red square in the corner showing that this is a right angle. So across from that right angle, that is going to be our hypotenuse. So I'm just going to start to label these. Drop my Apple Pen. So I know 12 is my hypotenuse. And then 8. So I've got my theta here. Remember, that's our unknown angle. So the side length across from that, we call that the opposite side length. And I'm just going to abbreviate those with op. And then we've got our other side length here, which we actually don't know. But the name that we use when we refer to this side length, it's actually adjacent to theta, our unknown angle measurement. So it is our adjacent side length, which we use with ADJ, adjacent. So one thing you need to remember here, in order to find that missing side length, we have to use the Pythagorean theorem. So remember, Pythagorean theorem, a squared plus b squared equals c squared. All right, so I'm just considering a squared. A is going to be my adjacent side, plus b squared. So b is going to be that side length of 8, so 8 squared, equals c squared. C is our hypotenuse. So remember, c is always the hypotenuse, so that would be our 12 squared. All right, now we just do some algebra. Yay. So we've got a squared plus 64 equals 144. Subtract 64. A squared is 80. So then to figure out what a is, to isolate a, we need to take the square root of both sides. So a is the square root of 80. However, I know 80 is an even number. We need to see if we can simplify this radical by any means. And we can. So I know 16 times 5 is 80. So I could rewrite this as 80 equals, root 80 is the square root of 16 times 5. From there, I can take the square root of 16, which is 4. And then the square root of 5. 5 is a prime. We can't take the square root of that. So it's just 4 root 5. So that's really nice. So now I know my adjacent side length here is 4 root 5. Okay, so from here, now I think we're all set. We've got all the means necessary to find our 6 different trig functions. So just to recall, so sine, you can abbreviate that by saying, I usually use sin, theta. So we all know, remember our SOHCAHTOA, put it big up there at the top. So we learned before, SOHCAHTOA is the tool or the mnemonic device we use when solving these right triangles. So the S stands for sine. Sine is the opposite over the hypotenuse. So I can write this as opposite over hypotenuse. And now we actually have these values in our triangle. So the opposite, it's nice when we label them because then we don't have to keep thinking, oh, which is the opposite, which is the hypotenuse. I just label them right off the bat. So opposite is 8, hypotenuse is 12. So my sign is, we must simplify, it's 2/3. All right, now we'll do cosine. So cosine, we can simplify or abbreviate to cos theta. So from our SOHCAHTOA, the C in SOHCAHTOA stands for cosine. AH stands for adjacent and hypotenuse. So cosine is adjacent over hypotenuse. So the adjacent side length, which we found out using our Pythagorean theorem, is 4 root 5 over the hypotenuse, which is 12. But we need to simplify. So 4 divided by 12 is going to leave me with a 3 in the denominator and root 5 on the top. And I'm good here. All right, so now let's do tangent. So remember tangent, I abbreviate that with just tan theta. And I rarely ever write these all out. I always use just my abbreviations here. So from here on forward, you're only going to see abbreviations from me, and that's fine for you as well. All right, so tangent, in SOHCAHTOA, that's what that T stands for. So O and A are opposite over adjacent. All right, so our opposite is 8 over our adjacent, which is 4 root 5. We're going to simplify that. 8 divided by 4 is 2 over the square root of 5. However, there's a big thing we can't leave here. This is not correct. You must rationalize. So remember, we learned this before, but you cannot have a square root in the denominator. So I'm going to kind of highlight this and say we need to rationalize. So remember to rationalize. We're going to take whatever that value is under the square root. So root 5, I'm going to multiply this by root 5 over root 5. Then I just multiply straight across. I multiply numerator with numerator. Now in our numerators, I've got 2 times square root of 5. We cannot multiply 2 times 5. Remember, you can only multiply what's beneath the radicals together. So the numerator will just be 2 root 5 over the denominator. So I've got root 5 times root 5. So I do multiply this. So I'd have the square root of 25. But I can simplify that. I'm going to erase my Pythagorean work. Just a little more room. Okay, so I've got 2 root 5 over. So the square root of 25 is 5. Perfect. So that is our tangent. All right, now we've got 3 more functions. So we need to find out the secant, cosecant, and cotangent. However, I am going to write them first as cosecant. So cosecant, I write it with my abbreviation. Oops, excuse me, that's cosine. Cosecant, CSC of theta. So cosecant goes hand in hand with sine. It's actually the reciprocal of sine. So 1 over sine is cosecant. That's another way we could write this. Thinking about it in terms of opposites and hypotenuse. Since it is the reciprocal of sine, and sine is opposite over hypotenuse, this must be hypotenuse over opposite. Okay, so we can now just use, actually we already found our sine up here. So I can use, knowing that it's 1 over sine, I can use that information. So I can just take the reciprocal of sine. So if sine is 2 over 3, or our hypotenuse and our opposite 8 over 12, I can just have this as 12 over 8, which is 3 over 2. All right, then we have our secant. Secant we abbreviate with SEC of theta. Secant is 1 over the cosine of theta. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So here, I could start by using just my angle measurements, but since I know it's the reciprocal of cosine, I'm going to just start with this value here, with my kind of final cosine value, my simplified cosine value. Because I think this looks like a little easier number to work with than this other number. All right, so I'm going to take 3 over root 5. However, we need to rationalize. Remember, we can't have square roots in the denominator. So just like I did here with the tangent, I'm going to multiply the square root of 5 over the square root of 5. I'll come up here. So that is 3 over root 5 times root 5 over root 5. and we multiply across. So 3 root 5 over 5. It would be over root 25, but then we already know that is root 5. All right, so I will box that in. Maybe I'll box all of these in so we know our final answers. All right, then we're left with cotangent. Ran out of room down here, I'll go up here. So cotangent, we're going to abbreviate that with COT theta. It is 1 over tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So I can now take my tangent value. Where's my tangent? So we had root 5 over 3. No, excuse me. 2 root 5 over 5. So I can now take the reciprocal of this to write the tangent. However, in this case, I know all of these are equivalent values. So over here, I simplified tangent to be 2 over root 5. So I can actually, since this is equivalent, I could take the reciprocal of this, because this is an equivalent value with 2 root 5 over 5. And if I take the reciprocal of 2 over root 5, I get root 5 over 2. And I'm going to choose that because that's already rationalized. I don't have to do any sort of multiplying of some value equivalent to 1. So I am good. So cotangent is root 5 over 2. All right, so one trick I have for you guys here, one tip. When you are, we often get confused as to secant and cosecant if they go along with sine and cosine. So one trick that you can remember, so our different pairs, remember sine goes with cosecant. So maybe I'll add this up here at the top. So sine goes with cosecant. Cosine goes with secant. And tangent goes with cotangent. Sorry for the messiness on this one. But I just want to give you the visual here. So one thing I want is you guys to see that there's going to be a co. In each one of these pairs, there's only one co. So we've got our co here. We've got cosine going along with secant. And then tangent goes along with cotangent. So there's only one co in each one of those pairs. Okay? All right, so let's move on. So now what we're going to be talking about are different angles, and especially specifically the rotation of angles. All right, so when we talk about angles, angles are in standard position when the vertex is at the origin. All right, so here is the origin, right? Our vertex here, remember the vertex, that's the little pointy part of the angle. When the vertex is at the origin and one ray is on the positive x-axis. So the positive x-axis is, I'll just highlight it here. This is the positive x-axis. So here, both of these, we've got our positive x-axis there. It's that part that I highlighted in yellow. All right, and then the vertex, maybe I'll color the vertex green or highlight it in green. So our vertex is there in green. And the vertex is right there at the origin, right? All right, so we've got two different sides. All angles have two sides, and these sides have special names. So we have the initial side. And that initial side is the side right there along our positive x-axis. And it's located there in blue too. So this is the initial side. And here's our initial side of this angle. All right, so then the other ray, so the other side of our angle is called the terminal side. And that side could be in any of those four quadrants. Sometimes it's even right back along, it could be on the same side as the initial side. If we had a 360-degree angle, that angle is going to have the initial side and the terminal side back there along that positive x-axis. Okay. So we've got two different ways angles can rotate. We could have a positive rotation. So positive rotations, their initial side starts here. They're going to rotate in a positive direction. So positive direction means counterclockwise. Then angles can also rotate in a negative direction. So if they're rotating negative, yeah, they start, once again, they always start there on that initial side being right there on the positive x-axis. But in this case, it's rotating in a clockwise direction. And that just makes it negative. All right, a couple other key features you want to make sure that you're knowing. 0, these are some values that I like. They're great to memorize because they're going to help you when you're actually drawing these angles out. So remember, 0 is going to be here, 0 degrees. 90 degrees is formed right there at the top, essentially, of our y-axis. 180 degrees is formed, it makes a straight line with your initial side. 270 is down there along the bottom. And then back to 0 over there, or you can even think of it back to 360 degrees. All right. So moving on down. So an angle of rotation is formed when we're rotating the terminal side and keeping the initial side in place. So just like we said before, counterclockwise indicates positive rotation and clockwise indicates negative rotation. So the big thing here I want you to notice is that angles are not limited to be between 0 and 360 degrees. No, angles can be much, much larger. What that means is that angle has been actually rotated more than 360 degrees around. So this example here, we've got a 390-degree angle, positive angle. So it's positive. So we always start. So I've got my initial side here. And I'm going to start rotating. So I start rotating up. When I rotate, I think about where I'm at. So I say, okay, I'm at 90, I'm at 180, I'm at 270, I'm at 360. All right, I have 30 more to go because 390 minus 360 is 30. I have 30 more degrees, and there I am. So this angle you must draw with that little spiral coming around to indicate how many times you have rotated. All right, and then we draw our terminal side. So that ray represents the terminal side of our angle. Yeah. So a couple important features to know. Remember, 360 is a complete rotation. 180 is a halfway rotation. So meaning you go kind of forming a straight line. All right, so we've got an example here. We need to draw some angles in standard position. So first thing I always do, draw out my axes. All right, now I look at my angle. So it's 320 degrees, and there is no negative sign, so it's a positive. This is positive. So since it's positive, I know my angle is going to be going counterclockwise. All right, so remember, we start. Initial side is right here. Always draw your initial side length. All right, and then we're gonna draw a little arrow around to represent where we go. So I'll do my arrow in green. So my angle, actually, it starts to rotate. All right, right there, I'm at 90 degrees, but I need to keep going. It's at 320. All right, keep going. It's bigger than 180, so I'm gonna keep going. Bigger than 270, keep going. However, it's less than 360, so I'm not gonna come all the way back up to that red initial side. It's about here. It's about 40 degrees less than 360. So I'm gonna now draw my terminal side. All right, to indicate that that angle has rotated, I'm gonna draw another little arrow here. And this green represents theta being 320 degrees. Okay, let's do the next one. So we've got 110. So I'm gonna first draw out my axis. Remember, we always start there in the positive direction. Then it's going to rotate in a negative direction. This is negative. So that means we're going clockwise. So I'm going to start down here. So I'm going to rotate, I'll do my green. The angle is going in this direction. All right, so here, so thinking in kind of in a backwards sense for my my rotation. Once I rotated down here, I'm actually at 90 degrees, negative 90. I need to keep going. My angle is negative 110. All right, so thinking about it, up here would be like a negative 180 degrees. Here would be a negative 90 degrees. So negative 110, it's going to be in between 180 and 90. It's going to be closer to 90. It's about 20 degrees past 90. So I'm going to keep rotating here, stop. And I draw my terminal side. Now it doesn't have to be precise, guys. As long as your labels are precise. Negative 110 degrees. Okay, and the last one, 990. So this is a huge angle. Well, it's just an angle that's been rotated a lot. So I'm going to start, we're going to draw our axis. So it's positive. So which way am I going? Counterclockwise, good. CCW, we'll say. So we always start, our initial side is right there. I'm going to start by rotating. So 990 degrees, that's as big. So I'm going to start, I kind of kept a little tally sheet on the side because I did all of this in my head. Well, on paper in my head. So I'm going to start, I'm going to rotate. All right, I know 360 brings me back here. So if I take, here's my my little notes cheat sheet. So if I had 990, I've rotated back 360. So I'm going to subtract 360 to see how much left of rotating this angle needs to do. So we still have 630 degrees to go. So this is bigger than 360. So I'm actually going to rotate one full revolution. These are called revolutions, all the way around again. So I'm going to keep going all the way back. Once I get back there, I've gone another 360 degrees. So I'm going to subtract that. All right, I've got 270 left to go. So 270 is a wonderful angle because I know that is right here in this negative y-axis. So I'm going to rotate around. There'd be 90, 180, 270. Boom, there I am. Then I draw my terminal side. And there's my angle, my 990 degree angle. Okay. All right. So coterminal angles. So coterminal angles are angles in standard position with the same terminal side. So for example, angles that measure 120 degrees and negative 240 degrees are coterminal. They have the same terminal side. Same terminal side. Okay. So a couple things we need to point out. There are infinitely many coterminal angles. And if you think about that, if I were to rotate, I could continue, I could rotate around, I could do it. There's an infinite number of revolutions I could do around this to find more coterminal angles. I could just keep rotating to find more and more and more. And you can also rotate in the negative direction. So you rotate in a negative direction, you're finding more and more and more coterminal angles. Coterminal, same terminal side. So an easy way to find the coterminal angles, first thing, I always draw them. Second thing, you can simply add or subtract 360 degrees or any multiple of 360 degrees. And that's the same thinking. When I just said we could continue to rotate around and make more revolutions, what we're doing is actually adding 360, add 360, add 360, or subtracting 360, subtracting 360. An infinitely number of times. All right, so that's going to be a nice, nice way to do it. So we add or subtract 360. Okay, so we've got a couple angles here. So first thing I do, I need to draw my angle. Yep. Okay. So it says we need a positive angle and a negative angle. So we need to find two coterminal angles. So remember, a positive angle isn't going to just be a positive angle, right? Negative angle is going to have that negative sign. They rotate in opposite directions. But we'll be good. All right, so I've got my angle theta, which is 65 degrees. So first thing I need to do is make that angle measurement. So this time I'm going to make my initial side, my terminal side, the same color, blue. So 65 degrees, it's greater than 0, but less than 90. So it's somewhere up here. It's probably a little small, but that's okay. So here's my theta, 65 degrees. So I need a coterminal angle. So I need a positive angle that has the same terminal side. So remember, this is the terminal side. I'll make it yellow. I guess I will change it. So thinking of a different angle, I can make a positive angle. So I can use the formula. They said we can use the formula. So we could take our 65 and add 360 degrees. So 65 plus 360 gives me 425 degrees. There is a positive coterminal angle. So let's draw that. So if I were to draw that, there's 360 degrees, but we need to go another 65. And there it is. It comes right back to the same terminal side. That is a positive coterminal angle, same terminal side. Now we need to find a negative. So negative. All right, so we can use our same formula here, guys. I can take 65 degrees and subtract 360. So 65 minus 360 is going to give me negative 295 degrees. But let's look at that here on my our sketch up there. All right, so I guess I'll use red for this one. So if we're starting here in our initial side, I'm going to rotate in a negative direction. So negative 90, negative 180, negative 270, boom, negative 295 is going to bring me right back up there to where we were at, same terminal side, that yellow side. All right, let's do it again. So for B, draw your axis, then you're going to draw your angle. So we've got our initial side always here. We're going to rotate. So this is 410, so it's going to go around more than once. So there I'm at 360. I need to keep rotating up, up to about 50 degrees. This is a different color. Oops, sorry. There we go. All right, so there's our angle, 410 degrees. Theta is in green. All right, I need a positive coterminal angle. So I can honestly see one right here. So I could, and remember, there are infinitely many of these. So just because I do it one way, maybe you think of another coterminal angle. There's not just one right answer. So for this one, I can see here a positive angle measurement that I can just look at my drawing and see. So I can see here, I'm going to do it in red. If I were to start here in my red, and in my blue initial side, rotate up, this angle here is a positive angle measurement, and it has the same terminal side. And what this angle is here is 50 degrees. And I can just see that from looking at my drawing. However, to get 50 degrees, you would take 410 degrees and subtract 360. But hey, didn't we say if we subtract, we're going to get a negative angle? Well, we thought so, but it's not always the case. So you might have to subtract 360 more than once to actually get that negative angle. Or you might be adding 360 and you're still going to be a negative angle. Because depending on how many times your angle has made that revolution, that's going to determine how many times you're going to have to either add or subtract 360 to make your angles positive or negative. So 410 minus 360 is 50 degrees, but that's a positive number. So it's a positive angle. However, what if we went once again? What if we rotated in the negative direction, or what if we subtracted 360 again? So if I subtract 360 again, I'm going to get a negative angle measurement. So we're at 50 now. I can subtract 360 again from 50. So 50 minus 360. That's going to bring us back all the way around to negative 310. Okay, and if I'm thinking about that, if I'm drawing that, I'll draw it in black. I would start here, and if I rotate in a negative 180, negative 270, boom, negative 310, excuse me. That's my negative 310 degrees, which is coterminal. Same terminal side. That yellow side is still their terminal side. All right, so be careful. Might not just add or subtract one time. All right, so for an angle that's in standard position, there's another angle that we are going to use. I love these angles. These are my favorite. We're going to talk about them all the time with our unit circle coming up. So for an angle theta in standard position, the reference angle is the angle. It's a positive angle. It's always positive. Always positive. It's a happy angle. No, it's always positive. And it's always acute. So what does acute mean? Less than 90 degrees. All right, so let's highlight. The highlighter. So it's an acute angle. It's positive. It's formed by the terminal side of our angle. So we talked all about those terminal sides. So in this specific drawing here, sketch, the terminal side will be here, this yellow side. And the reference angle is the acute angle formed. So acute, remember, it's going to be the reference angle. It's going to be between 0 and 180 degrees. Okay. So yeah, there it is. It's the acute angle. So I always think too, it's the angle formed by when you're trying to get to the x-axis. It's going to be the closest angle to bring wherever your terminal side is to the x-axis, depending on which quadrant you're in. All right. So let's find our reference angles. So we've got this first example here. I drew or typed out the drawing for you there. We've got our angle of 135 degrees. So we can, I would actually prefer if I had my axes drawn in. So I've got our 135 degrees there. So the reference angle, that's going to be this angle formed between the terminal side and the x-axis. So to find out what that value is, remember this entire x-axis, that's 180 degrees. So I can take 180 degrees and subtract 135, which is going to give me 45 degrees. So this reference angle here is 45 degrees. All right, how about B? So for B, I am going to start by doing a sketch. So I'm going to sketch my axis. We've got a negative 105. So I'm going to start my rotation of my angle. Oh, by the way, this one rotated. So initial side is always there. So I'm going to rotate in the negative direction. So there's a negative 90, but I need to go to negative 105. Oh, that's about there. Like I said, it does not need to be exact. Just make sure your labeling is clear. Hold on, with that label, it's not very clear. Oops. So then our terminal side, I'll make it yellow as well. Oops, it's red still. That's okay. Is there. So that red angle, that is -105. And I need to find the reference angle. So remember, the reference angle is the acute angle. So it is going to be the angle. I'm here on my terminal side. I need to say, where is the x-axis? It's up here. So what is the fastest angle or the smallest angle to get there? This angle right here. That is my reference angle. So in this case, once again, I've got 180 degrees. We've taken away 105 of it. So if I have 180 degrees, I subtract 105 degrees. Actually, I'm going to draw this. I'm going to make sure, whoops. Make sure our angles are that it's showing that it's a positive. So I'm just changing this to be like this. So it's in a positive direction. So you guys know, remember, these reference angles are always positive. So 180 minus 105, that gives us 75 degrees being our reference angle. All right, then the last one, we've got 325 degrees. So I'm going to draw my axis. I'm going to draw my angle. There's my initial side. I need to rotate it. So 325, it's bigger than 270, less than 360, it's about there. All right, so if this is theta 325 in red, the reference angle is going to be this angle. The acute angle formed between the terminal side and the x-axis. So for this one, if I take 180 and I subtract 325, it might help me out, but I really think that this entire value could be 360 degrees because this angle is rotating all the way around. So I'm going to take 360 and subtract 325. Now you might look out, there are some formulas for finding the reference angle. They're different for each quadrant. I'm not really going to give you those formulas. I think if you draw a picture, you can think about it and say, okay, what math is going to help me to find this angle? All right, so 360 minus 325 is 35 degrees. Okay, another way we could have done B here, now that I'm thinking about it. Yeah, that's okay. We're good. All right, and one other thing I do want to point out. So if our angle is, let's say I had theta, I'm going to add example D here. So if our angle theta, let's say it is 50 degrees. All right, it is here, 50 degrees is up here in quadrant 1. What would be the reference angle? Remember, it's the acute angle formed between the terminal side and the x-axis. So it's actually the same angle. So if you are in quadrant 1, theta is equal to the reference angle. Okay? All right, so last thing for today. So we need to determine the value of trig functions for any angle in standard position using a coordinate point. All right, so let's say I'm going to start by drawing a sketch. All right, so it says we're finding angle theta in standard position, so we know that it's coming off the x-axis. We need to begin by selecting a point P with coordinates x and y on the terminal side of the angle. So I'm just going to pick x and y. I'm going to pick any point here. I'm just going to pick one here. I think your book gives you an example of one. in the second quadrant. I'm in quadrant 1. And this point I'm going to call x, y. And we say that this is on the terminal side of my angle. So I'm going to draw my angle here. Remember, it's coming off of here. This is my angle theta. All right. So it says the distance r from the point P to the origin. So this is P. P is xy. To the origin here. We're saying this distance is r. So they're saying this is r. The distance from the origin to the point. All right. The distance is given by the square root of x squared plus y squared. So this actually comes from the Pythagorean theorem. So if I want to, I can, because remember, we're trying to find the trig functions. So our way of solving those is by using a right triangle and by using all of our different side lengths. So I'm trying to create a triangle here. So I am going to create a triangle. So the easiest way, you need to make a right triangle by taking that point, and you are going to form a line perpendicular to the x-axis. Make sure it's perpendicular to the x-axis. Do not make it perpendicular to the y-axis. You will not get the correct measurement there. So it's going to be, I'm forming my right triangle here, coming straight down. So if I were in this quadrant here, I would come straight down. If I were in this quadrant, you need to come straight up. This quadrant, straight up. Make sure you're coming to the x-axis, not to the y. All right, so we know that that length is r. So if we know this is a coordinate point, oops, with the values of x and y, I know the side length here at the bottom of my triangle. I know this length is x. I came x units out from the origin, and then to go up to that coordinate point, I ran up here y units up and down in the y direction, positive direction. All right, so thinking about this, I've got x, y, and r on a right triangle. Hey, I mean, I could redraw this as another triangle, right? I'm just drawing the same triangle here. So we've got r, we've got x, we've got y, we've got theta. So these are, so remember, if that's theta, we've got our opposite side. X is going to be our adjacent side, and r is our hypotenuse. All right, so knowing all of those, opposite, adjacent, and hypotenuse, we can find easily our 6 trig functions. So I'm going to list them out here. So I have sine, cosine, tangent, and then I'm going to go secant, secant, cotangent. All right, so remember, sine is opposite over hypotenuse. So our opposite is our y, our hypotenuse is our r. Cosine, adjacent over hypotenuse. So our adjacent side length is x, so it's x over r. Our tangent is opposite over adjacent, so that's going to be y over x. All right, and then cosecant, secant, and cotangent. Remember, they're just reciprocals. So it is 1 over sine. I'm writing this again because the more times I write this, the more I remember it. So that's hypotenuse over opposite. So that's going to be r over y. Secant is 1 over cosine. So that is our hypotenuse over adjacent. So that is x over r. And then cotangent is 1 over tangent, which is going to be adjacent over opposite, which is x over y. Okay, and these are it's going to be really helpful for you guys here. So just kind of to recap, we're going to always start by making a right triangle in your plane. You need to drop that side length straight to the x-axis, or drop it straight up to the x-axis to form a right angle with that x-axis. All right, so there's your book here. That CK12, I think they had an error on this part, so I apologize if you saw something that was contradicting. Okay, so we've got our last example here, and we'll be done with this lesson for today. So I'm gonna make actually my steps. I like to write my steps out. You know, I write those on the board, so we'll do it here on my iPad. So first thing we need to do, always draw a picture. All right, so it says we need to find the values of p of -6, 9. So first thing, I'm going to draw a picture. So I draw my coordinate plane. I need to plot -6, 9. So 1, 2, -6, 9, 1, 2, 3. There's my point. P, -6, 9. Okay. All right. So I'm going to connect. Remember, they say that this this point is on the terminal side of our angle. So our angle is here. That's our theta. But the nice thing, we're going to actually use our reference angle here as our theta because they actually have the same trig functions. So what we need to do, we've drawn our picture. We drew our theta, but we still need to find the 6 trig functions. So step 2, we drew our picture, we plot our point, and our angle. All right, so the third thing, you need to make a right triangle with your point. That includes your point and the x-axis. So remember, this needs to be perpendicular. This is our sign for perpendicular. So I'm drawing this straight down. Boom. Perpendicular, we mark with our right angle. So there we go. I've made a side length. So now what I've actually done here is formed a triangle. So this triangle here, we've got this side length, we've got the green side length and the black hypotenuse. And then we've got our angle theta there. We've got the reference angle here. So actually, if it's helpful for you, some kids I think like to redraw the triangle outside of the coordinate. If you don't mind, you can just leave it in there as well. All right, so we've got our -6, we've got 9. And okay, and those values, how do I know those values? So remember, I know x and y. So I know x has come out here in the -6 direction. I could count here, so that's -6. And then in the y direction here, we've actually went up 9 units. So I know that's 9. But I still need to find my hypotenuse. So to find our hypotenuse, that'll be step 4. And it's not always, well, yeah. So we're going to use the Pythagorean theorem to find our missing side length. Okay. All right. So we need to find this, right? We need to find our hypotenuse. So remember, Pythagorean theorem, we've got a squared plus b squared equals c squared. This will be, I'll color in blue. It's this step. Okay, so we can take, as It doesn't matter if 9 or -6 is your A and your B. So I'll take -6 squared plus 9 squared equals C squared. So I have 36 plus 81 is C squared. 117 is C squared. So we take the square root of both sides. So C equals, I'm just going to flip-flop the order so it's more logical for us. Square root of 117. However, 117 we can simplify. That's actually 13 times 9. Remember, I picked that number because 9 is a perfect square. I can take the square root of 9 and simplify this to C equals 3 root 13. All right, so now we know that missing side length. I'm going to label it up here. 3 root 13. I'm going to label it here, 3 root 13. Okay, so now we've got all of our components that we need. If I have my pen. Okay, all right, so now we know all of our opposite, adjacent, hypotenuse, so we can find all of our trig functions. So sine of theta, cosine theta, tan theta. So sine. Remember, this is our theta here. So our opposite is 9. Our adjacent is -6. And it's really important that you keep that negative in there, that you know, because it's going to affect our different trig functions. So depending on what quadrant you're in, you're going to have different values being positive and negative. Maybe I'll go into that a little more, but so just going on my tangent here. So in our different quadrants here, we've got quadrant 1, it's going to be positive, positive. Quadrant 2, we've got negative, positive. Quadrant 3, you have negative, negative. And then quadrant 4, whoops, you have positive, negative. All right, so depending on what quadrant you're in, remember your values are going to have different signs, or different positive and negative values. All right, so sine of theta, opposite is 9. I'm not going to write my O and H. I'm thinking we're getting these now. I'm just going to put the values 9 over 3 root 13. This is 3 over root 13. However, I need to rationalize. So I multiply by root 13 over root 13. 3 root 13 over 13. Sine. All right. Cosine. I'm going to run out of room. So cosine is our adjacent. So -6 over 3 root 13. So we'd have -2 over root 13. We must rationalize. Multiply by root 13 over root 13. So -2 root 13 over 13. All right, and then tangent. Tangent is opposite over adjacent. So 9 over -6, which is -3 over 2. Then we'll just find the reciprocals there to find our other 3. So remember, we need to take the reciprocal of sine to find our cosecant, reciprocal of cosine to find secant, and the reciprocal of tangent to find cotangent. All right, now you have practice. Good luck.